Solving systems of equations in two variables means graphing it and finding the point of intersection of the two lines if a point exists. There are three things that happen when we graph systems of equations in Algebra 1. One thing that happened was we would graph two lines and they would intersect at one location. We would say that that system had one solution. In pre-calculus, we call this system consistent and independent. Another system where intersections occurred was when we graphed two lines, but when we graphed it, it was actually the same equation. We had two equations, but they were the same line. We called that many or infinitely many solutions. This system is consistent and dependent. The third thing that could happen was you could graph two lines on a coordinate plane, and they're parallel, which means they never meet. This was no solution. And when a system has no solution, we say that it's inconsistent. And apparently I keep spelling this word wrong. We learned three different methods to solve a system of equations, and I'm going to do this same problem three different ways. There is a fourth method that you may or may not have learned in Algebra 2 depending on your teacher. So the first thing we learned how to do was to graph this by hand, which this particular one is kind of nasty only because when you solve the equations for y. So I'm going to solve this equation for y by subtracting 7x from the other side. So what? Oh, I'm sorry, it's not nasty. Never mind. Y is equal to negative 7x plus 9 is one of the lines. This one has a y-intercept of 9, so I'll put a dot on 9. And the slope is negative 7 over 1, so I'd go 1, 2, 3, 4, 5, 6, 7 down and 1 to the right. 1, 2, 3, 4, 5, 6, 7 down and 1 to the right, and that's where my line would be. I don't think I'll draw it very well here, but here's my line. The second equation, when I solve it for y, first I'm going to subtract 5x from the other side, but when I do that, there's still a negative 1 in front of the y, so I need to divide everything by negative 1. And I get the equation y equals 5x minus 15. I don't actually have 15 for a y-intercept here on my particular graph, so I'm going to have to play the game of what if x is 1? So make a little table. So when x is 1, y is negative 10, so it's down here. And then from there, I can either continue my table or I could just use the slope to plot more points. So it's up 5 to the right one. So 1, 2, 3, 4, 5 up, right 1, 1, 2, 3, 4, 5 up, right 1. And there's my line. And look, there's my point of intersection, which is at 2, negative 5. The second method we learned for solving systems of equations was called elimination. The way elimination worked was you would solve one of the two equations for one of the variables. So I'm going to solve the first equation for y, and then you would substitute that expression into the other equation in place of the y. So I'm going to plug in the negative 7x plus 9 in place of the y. When you do substitution, one of the two variables goes away. In this particular problem, I would need to distribute the negative, and I would get positive 7x minus 9. I would need to combine like terms. 12x minus 9 equals 15. Add 9. So 12x is equal to 24, and then divide by 12, and I find out that x is 2. Once I find out x is 2, I can plug that back into one of the original two equations, and it doesn't matter which one. It's actually faster if I plug it into this equation in order to find out what x is. What did I solve for? I solved for x. X is 2. I need to know what y is. So if x is 2, I would plug in 2 for x, and I get 14 plus y equals 9. Subtract 14, I find out y is -5. So I still find out that the solution is 2, -5. The third method we learned in Algebra 1 was called elimination. Elimination was the one where you would add the two equations together so that one of the variables eliminated. It just so happens that if I add these two equations together, the y's cancel because they're opposites. So these go away, and I'm left with 12x is equal to 24, or x equals 2, and plug it back in, and I'm going to find out y is -5. The graphing calculator can also be used to find where two lines intersect, if they intersect, using a function on the graphing calculator called intersect. I'll let you know where it is. In order to use the graphing calculator, you need to have the equations in slope-intercept form. So you need to change the first equation to y equals -7x plus 9, and the second equation to y equals 5x minus 15. Just like we did in the very first example in this lesson. And then you would put this into y1 equals and this into y2 equals under the y equals function. And then you look at the graph, and you should see this, in which case you actually see it intersects. And then I want you to press second trace. Press second, and then press the trace button, which is up here at the top of the calculator. And I want you to notice option number 5 here says intersect. That function will find where things intersect. So in order to find the point of intersection, I usually tell students to do second trace, number 5, and then hit enter 3 times until you see the word intersection or intersect at the bottom of your screen. If you don't hit enter enough times, you'll probably see words like first curve, second curve, and guess. That's why you hit the enter button 3 times. You want to basically, you're telling it you want to find the intersection of these two lines. Until you see the word intersection at the bottom of the screen, you haven't found it, but look, it told me where it intersected. Again, that function is once you put the equations into y equals, second trace 5, enter, enter, enter. There is a fourth method for finding the intersection of two lines, and it's called using a matrix. A matrix is a collection of numbers between brackets. And what we're going to do is we're going to pick only the coefficients from each equation. So the first equation, just the coefficients are 7, 1, and 9. And I'm going to write it like this. In the second equation, the coefficients are 5, -1, and 15. Matrices has something called dimensions. That means we want to know how many rows and how many columns they have. So this is called our dimensions. And in this particular case, there are 2 rows and there are 3 columns. And the way that we write 2 by 3 is we use a little x. I know it looks like it says 2 times 3, but it's not. It's 2 by 3. The reason that's important is because when we plug this into the calculator to solve for us, we need to know the dimensions of this matrix. So now I want you to find second x -1. Again, press the second button, and then I want you to find the button that says x to the -1st power. It is on the left-hand side. This is called the matrix function, and you probably won't see the same thing on your screen that I see on mine. We're going to work with matrix A here. So what we do is once we go to second x -1, we're going to move the cursor 2 units to the right to edit. and then we're going to hit enter so that this pops up on your screen. Again, you may not see what I see on my screen because I've used this calculator to do other things, but you should be somewhere where it says matrix A and then there's some numbers up here and they may be different. If they are, all you have to do to change them is hit 2, enter, 3, enter, and it'll change the size of your matrix. You can have any number of rows and any number of columns that you want in a matrix. For this particular problem, there will be 2 rows and 3 columns. In another lecture, we'll talk about 3 rows and 4 columns. So what happens is if you hit 2, enter, 3, enter, the cursor ends up moving here. What you're going to do is you're going to change these numbers by typing them in and hitting enter. When you do, you should see a little bit of information where that red box is right now, and it'll tell you what you typed in. If you don't hit enter, it won't lock the number in. So for this particular problem, you're going to hit 7, enter, 1, enter, 9, enter, 5, enter, -1, enter, and 15, enter, so that this should be on your screen. Now once we have the numbers typed in, we're going to quit, and the quit function is second mode. Mode is at the top of the calculator, so press second mode and it goes back to the home screen. Then we're going to go back into the matrix function again, second x -1. So quit and then go back to second -1 again, but this time I want you to go to the math function. And then I want you to scroll down. It's probably, you have to scroll down until you find this. We're going to look for something called RREF. I'll even tell you what it stands for. It stands for Reduced Row Echelon Form. All you care is that it's the function that's going to solve systems of equations for you. So now you're going to hit enter. So RREF, open parentheses, opens on your home screen. Once that does, you're going to go back into matrix a third time. So go back into second x -1, but stay with the cursor on names, and then hit enter twice. And you should see this. And I want you to notice that that last column is the solution. We'll talk about this on another day, but for right now you just need to know that that's x and that's y and that it solves the system for you. So you now have 4 methods for solving systems of equations.